Assalamualaikum warahmatullahi wabarakatuh. I will explain about the introduction of my video. It is about a mini project that has the objective, which is to conduct soil classification project within the vicinity of my area. And then the second one is to collect soil samples and conduct soil experiment and describe the soil in terms of water content, particle density, particle size, grading and texture, fluid density and also the permeability. In this video, there is a methodology of the experiment, finding, discussion and also the conclusion.
First, I take the mass of the tray that I use. Then, I put some of the soil sample on top of the tray. After that, I spread the soil sample all over the tray so that it can dry up easily. Then, I took the mass of the soil and the tray. After that, I put it outside under the sun. After 24 hours, I took back the soil and the tray. And finally, I took the mass of the dry soil and the tray.
So this is the finding of the water content. I get mass of tray is 85 gram and I label it as M1. For M2, which is the mass of wet soil plus tray, is 263 gram. And after the drying process, M3 I get mass of dry soil plus tray, which is 251 gram. Mass of water, which include the formula M2 minus M3 equals to 12 gram. Mass of dry soil, M3 minus M1 equals to 166 gram. And I get the moisture content by using the formula M2 minus M3 over M3 minus M1 times 100, which is 12 over 166 times 100, which is 7.23%.
First, I take the dimensions for all of the 3 jars. Then, I weight the jar with the lid. After that, I put some of the soil sample into all 3 jars and weight it again. Next, I pour some water until it reached about 3/4 of the jar. After that, I put all 3 jars into a container with plants. The plants can absorb the humidity. After 1 hour, I took the jars out and shake it. After that, I pour the water until the jar becomes full. I close the lid and finally I took the mass of all 3 jars. Next, I empty the jar and pour the water until it becomes full. And finally, I took the mass of it.
So this is the finding of the particle density test. I used 3 identical jar, and the mass of the jar plus lid, I label it as M1, mass of jar plus lid plus dry soil, M2, mass of jar plus lid plus soil plus water, M3, and then mass of jar plus lid plus full of water equals to M4. And then, after the experiment, I calculate the mass of dry soil by using the formula M2 minus M1, mass of water M3 minus M2, and then mass of water to fluid density bottle M4 minus M1. Then, I calculate the particle density of soil by using the formula mass of dry soil over mass of water to fluid density bottle minus mass of water. And then finally, I get the average particle density, which is 1.220 gram per cm cube.
First, I folded 5 papers into 5 different boxes. Then, I used some nails to make holes at the bottom of the box with the diameter 5, 3, 2, 1 and 0.5 mm. Next, I took the initial mass of the soil that I used. Next, I sift the soil into another tray by using one of the boxes. And finally, I took the mass of the soil that passed through the hole of the box. Then, I repeat the experiment for another 4 times.
So this is the finding of the particle size grading and texture test. So the initial mass of dry soil that I used is 300 grams. This is the data, which is I used 5 types of diameter of sieve hole, which is 5 mm, 3 mm, 2 mm, 1 mm, and also 0.5 mm. Then, by doing the experiment, I get the mass of soil that passed through the hole. And then, I get the mass of soil retained by subtracting the initial mass of dry soil with the mass of soil passed through the hole continuously. And then, I get the percentage retained in percent by using the formula mass of soil retained over initial mass of dry soil used times 100. And finally, I get the gravel size particles, which I assume retained at 5 mm, which is equal to 18.20%, and sand size particles, which retained at 3 to 0.5 mm, which is equal to 71.84%.
First, I cut the potato jar and tape it until it becomes a cylinder shape that is open at the top and the bottom. After that, I took the dimension of the cylinder and also the mass of it. As I am in UiTM right now and I can simply use the soil inside here, I use the container full with soil to visualize the site. At the side, I hammer the cylinder by using the rubber mallet and take it out after it becomes full. And finally, I take the mass of it.
So this is the finding of the fluid density test, which is the core kata method. For the height of cylinder H is 5.8 cm, diameter of the cylinder D is 7.5 cm. To get the volume of cylinder V, I use the formula V equals to pi d squared H over 4. And then I get the value 256.24 cm3. For the mass of cylinder W1 is 9.60 gram and the mass of cylinder plus soil W2 is 323.50 gram. To get the mass of the soil W, I use the formula W2 minus W1 and I get the value is 313.90 gram. For the unit weight of the soil, I use the formula W over V, which is 1.23 gram per cm cube, and the dry unit weight is unit weight of soil over 1 plus water content, which is 1.15 gram per cm cube.
First, I use nails to make holes at the bottom of the bottle. And then, I label the bottle with 4 level points, which are H1, H2, H3 and H4. And then, I cut the top of the bottle so that I can easily insert the soil. After that, I put the water bottle inside a container and I pour some soil inside of the water bottle. Then, I put some water until the water bottle becomes full so that the soil can become more saturated. And finally, I pour the water again and record the time when the water reach each level points.
So this is the finding of the permeability test, which is the constant head test. So this is the drawing of the water bottle that I used. I label the water bottle with 4 level points: H1, H2, H3 and H4. H1 is 16 cm from the bottom, H2 14.8 cm from the bottom, H3 13.1 cm from the bottom, and H4 11.1 cm from the bottom. As for the diameter of the bottle, it is 5.5 cm, and the cross-sectional area of the bottle, which I use the formula pi d squared over 4, is 23.76 cm squared. Then I get the head loss, which is the difference in level for each level point. I get 1.2 cm, 1.7 cm and 2.0 cm. Then I get the quantity flow Q by using the formula volume of cylinder, which is pi d squared h over 4. Then by doing the experiment, I get the time taken T, and then the difference in level L, which is the same with the head loss, and then I get the coefficient of permeability K by using the formula QL over AHT. And finally, I calculate the average coefficient of permeability K, which is 0.102 plus 0.089 plus 0.091 over 3, and then I gain the number 0.094 cm per second. So now is the discussion of all of the experiment. For the water content experiment, the water content is 7.23%, which means 7.23% of the soil contains water. It means that the soil is quite dry at the day of the experiment. As the precautions, the soil should be directly placed under the sun to make sure the soil dry completely. And then the second one, the experiment should not be done in a rainy day or the result will be no accurate. Then is the particle density test. Particle density of the soil is 1.220 gram per cm cube. The particle density is too low than common soil particle density, which is 2.65 gram per cm cube. So it is high in organic matter. As to precautions, always make sure that each jar is completely full when filling up the jars, and then make sure that the outside of the jar is dry to get accurate data. The third one is particle size grading and texture. I get gravel is 18.20% and then sand 71.84%. Most of the particle of the soil is coarse solid. It means that water can pass through the soil easily. As a precaution, when punching the holes at the paper, make sure that the holes has exactly the same size as the nail. The second one is the sieving must be done carefully so that no soil particles scattered on the ground. The fourth one is particle density test. The unit weight of the soil is 1.23 gram per cm cube, and then the dry unit weight is 1.15 gram per cm cube. It means that the soil is loose, porous, and rich in organic matter. The value of the dry density also proven that the soil has more pore space. As a precaution, the cylinder should be completely full of soil before taking it out. And then the second one is the weighing of the soil plus cylinder should be done quickly to avoid the soil from falling out from the cylinder. And then the last one is permeability test. The coefficient of permeability of the soil is 0.094 cm per second. This is the standard value for the mixture of sand and gravel soil. It means that the soil is permeable and water can easily pass through it. As precautions, use stopwatch instead of counting the time, and wear gloves when making the holes by using the nails to avoid any injury. Lastly is the conclusion of all of the experiments that I have done. So, the soil is dry, high in organic matter, mostly coarse particle, has more pore space, and high permeability. So, the soil is not suitable for plants even if it is high in organic matter, as the soil cannot hold any water. However, this type of soil is suitable for engineering structure as it will have a high compaction degree and high shear strength after the compaction process. There is also a lot of improvement that need to be done in each experiment to gain accurate result and to ensure safety. Lastly, I can say that all of the objectives for all of the experiments were achieved.